Yeah, hi everyone. So we have Kat with us to speak today. She is a PhD student at Curtin University in Perth. Kat is part of the International Centre for Radio Astronomy Research. She's a science communicator who has spoken on the radio and given a number of public talks, so you might have heard her on Triple J. She's a vocal advocate for equality and fair representation in science and has fought really hard to get women represented fairly within the New South Wales science curriculums. And this is what she's going to tell us about today. So take it away, Kat.
Thank you so much for the introduction, and thank you so much for having me on virtually today to give this talk. It is such an important discussion to even just start, let alone actually work towards doing something. So I really appreciate everyone taking the time to join in with this discussion. So as Isabel said, my name is Kat Ross. A bit of an introduction about who I am. I'm actually originally from Sydney University, and so grew up in Sydney and in New South Wales, but I've moved to Perth since then, and I'm currently doing my PhD with the International Centre for Radio Astronomy Research at Curtin Uni. So I'm researching baby black holes and AGN and the variability with the MWA telescope. Which is going really great, but I'm only about a year or so in at the moment, and that's not actually the main focus of this talk. This talk is going to be about my work on the side of my PhD with a campaign. But I want to go a little bit about who I am as a person and where I came from. And it all starts from my childhood. And actually growing up, I was a really big fan of two particular shows. Star Trek Voyager, mainly because Captain Catherine Janeway is an absolute total badass and I love her. It helped that she has the same name, so Star Trek Voyager was always my favorite. But I also loved The New Inventors. It was a show that I watched with my family, and one day I remember watching it and thinking, I would absolutely love to be an inventor. I think I could do it. There's not much to it. And I asked my mum, how does one become an inventor? And she basically just told me, you find something that's broken or you see something that could be better and you just invent something to fix it. So I remember that night looking around the house and being like, I don't like this at all because there is nothing that needs fixing. Everything is fine and working. So how am I meant to invent something? So that really frustrated me. And I think I pretty much gave up on my dream as being an inventor after that day. But this does actually bring up a really important topic, and that's role models in science. I mentioned Captain Catherine Janeway, and she was my biggest role model for a female in science because typically, even today, we still really only highlight the lone white male genius. This particular type of scientist, this one size fits all, which is just wrong. It doesn't really work. And in fact, if you still Google today a scientist cartoon, this is the first image that crops up. And actually pretty much every other image after this looks very similar. And that's just not a correct representation of what science is or who scientists are. But because of this stereotype that we have and this really narrow view of what a role model is for scientists, it means that when we ask students to draw scientists, the majority of the time they will actually draw very similar scientists to this cartoon. So they draw a typically male with a lab coat and crazy hair. Now, that isn't what science is. Ironically, when I went to draw myself as a scientist, I actually drew myself pretty much exactly that. I do have crazy hair, to be fair, but I don't wear a lab coat, and I haven't since first year chemistry. So even now, the stereotypes are still very much alive. The good news is, though, there was a study recently done in 2002 that found if you actually give students proper role models, if you show them that scientists are diverse and there are females that are scientists, there are people of color that are scientists, you don't need lab coats or crazy hair, you actually find that students then start to draw a more diverse representation of scientists. So these models that we have, these role models that we present to students are really quite damaging, but they can change. When we present proper representation, students learn to see different views of scientists. And that actually has a really great effect following through all the way up to studying science later on. And there's actually a measurable effect called the Scully effect. That's actually after the character in The X-Files, who was a female scientist, and she was one of few female scientists in media that young girls had access to be inspired by. But they found that after a few years, as these young aspiring female scientists grew up, that if they had watched The X-Files, they were 50% more likely to have worked in STEM fields or be working in STEM fields. So having these role models really actually increases the representation, and it shows these young girls that there are possibilities for you in science. So we really need those role models, and my only role model was Captain Catherine Janeway, and while she is amazing, it's a pretty limited view. And so my journey to physics was really, I think it's actually probably quite typical for many women. I actually went to a science camp. Again, we had a dress up as a scientist event, and I brushed my hair to make it even wilder and wore a lab coat and bow tie. Again, went with that very stereotypical view of what a scientist is, because I really just didn't have any other knowledge of what they could be. But at this science camp when I was in year 12, there was around 50% female. So it was quite good representation at the time. And I remember looking around being like, oh yeah, wow, there's lots of people that like science. I did go to an all-girls school. And I remember thinking my physics class and my maths class were both really small. But I remember thinking that was probably just because they're not very popular topics, or they're not very, interesting subjects that people want to take. I then got to my undergraduate, and I found that wasn't the case. People were doing physics and maths. It's just there weren't many people like me doing physics and maths. There was less than 30% throughout my entire undergraduate, and then that dropped to about 10% when I was doing my honours in astronomy at UC. So these numbers are really quite devastating, and they do decrease as you go to higher and higher academic levels. And it was really at this stage, at the end of my undergraduate degree, that I started an arguably more important journey, and that was my journey through feminism. I actually went to a talk by Professor Athene Donald, who is from the UK, and she does a lot of work with the Athena Swan model and working to increase representation for women in STEM. And as part of this discussion and this talk, she mentioned imposter syndrome, and it was really kind of like a light bulb moment for me. And I started to do a bit more research, because I never even heard of the term imposter syndrome. And I found that, first of all, women were more likely to suffer from imposter syndrome, and if they do suffer from imposter syndrome, are more likely to leave astronomy. I had no idea that there were actually these effects that could be measured and seen and traced just because of, not feminism, a lack of feminism, sexism really. And it was pretty devastating. And imposter syndrome really comes as quite an internal thing. You have a lot of voices in your head that are saying, you don't belong here, you're really not meant to be here, look around, there's no one like you here, so why do you think that you should be? And when you don't know that imposter syndrome is a thing, you hear all these voices in your head, and it becomes very hard to say that they're not true. But basically, when I learned that imposter syndrome was real, it was very much a step for me to say, this is all fake. This is actually just a symptom of a larger problem. But it really bothered me that I'd kind of gotten so far into my degree and I didn't even know about this. So I started doing a bit more research, and I found that there's also a measurable effect externally as well, that stereotype threat. If you explicitly bring up stereotypes that women aren't good at science, their grades can actually be dramatically affected. Even if you imply, so a purely implicit stereotype, we still see a measurable effect in a decrease of women's grades compared to their male counterparts. And there's also studies that show it's not just in grades, it's not just internalized, but if you present identical resumes and identical applications with randomized male and female, male applicants are seen as more hireable, more competent, they're offered more career mentoring, and on average $5,000 US more as a starting salary with completely identical applications. So at this stage, I'm pretty fired up. I've gone through however many years of studying. I've gone through an entire undergraduate degree through my honors, and not once has any of these issues ever been brought to me. I didn't know that there was ever really not just internalized issues with having this bias and sexism within STEM, but there's also external factors that will actively hinder my progression in a career in STEM. So it's pretty heartbreaking. I was pretty furious at this point, no shock there. But I also looked back and I realized that a lot of the things that people had said to me, and a lot of the things that I've really taken to heart, that have really kind of fueled that imposter syndrome, didn't actually necessarily come from a place that was true. They had really only come from a place that was just sparkling sexism. And these issues are around, and you know that a lot of the biases within STEM are still existent and can still impact students today, it becomes very clear the ways that it's already impacted you. And so I was pretty hurt that I could get so far in a degree, have to just deal with these things personally, and then only after I've left my degree realize that this wasn't because of myself. This is actually a much larger and much more complicated discussion and issue. So that led me to 2018. And in 2018, I was actually working with a group at Sydney University called the Physics Education Research Group. So the super group, Sydney Uni Physics Education Research. And as part of this group, we were working to help teachers with the introduction of a new physics course in New South Wales. So they introduced a new syllabus, and it was actually because in 2005, they'd noticed there was decreasing numbers of women enrolling in physics in New South Wales, and they wanted to try and feminize it. And the best way to feminize it, according to the research of the day, was to introduce things like essays and emotions in order to entice women to take physics. Not surprisingly, that didn't actually work in increasing the representation of women. There was actually still a decline. And so in 2017, they introduced a new physics syllabus that got rid of a lot of that essay-based information and a lot of the essay-based questions and focused more on the sort of pure physics, a lot more equations, and a lot of topics that hadn't really been taught until before 2005. So that's including quantum physics and thermodynamics, which are really quite complex but fantastic areas of physics. And I think that that's incredible to bring these things in, but we do really need to make sure that the teachers know how to teach this. And a lot of teachers in New South Wales aren't actually physics trained. So learning these really complex areas and then teaching it to students is quite demanding, and a lot of schools don't have enough funding to train these teachers properly. So that's where my job came in. It was our job to try and train these teachers and give them enough resources to be able to cope with the new complex syllabus. And as I said, this really came about because there were declining numbers for women in STEM. And I kind of wanted to look a little bit further into this. I was a little bit shocked that you would have a syllabus that's still declining numbers of women and then just kind of introduce this new one without really addressing that fact at all. At least in 2005, they had kind of tried to entice females to take it, but there was still declining numbers with this feminized syllabus, and the new one coming in made no real mention of trying to attract more females, and there was no real talk of how this would affect even low socioeconomic areas as well as women. It was often branded as something that was highly mathematical, highly technical, and these are all great terms, and I love a physics syllabus that's like that, but they're also terms that are often associated with the negative side of physics for people that are already on the edge of whether or not they should take it. Ironically, I almost didn't even take physics in year 11 and 12 because I was worried there was too much maths, even though I was already taking the highest level of maths. That makes no sense. All the maths in the physics syllabus can be achieved with a maximum year 10 understanding of mathematics. You don't actually need any maths in year 11 and year 12 to understand all the maths in the physics syllabus. So I was even deterred by the idea of having a mathematical science. So then we're branding this new syllabus as something that is highly mathematical. And I don't think it's any shock that we actually have already seen a decrease in the number of women that are taking this syllabus in the coming years. But this is where we were going through the syllabus dot point by dot point. And I was going through with a colleague and they noticed in radioactivity that Marie Curie wasn't mentioned. So I decided to go through because I was pretty shocked. If you are teaching radioactivity without Marie Curie, it seems like you're really missing a big part of radioactivity. She invented it. She even coined the word, 2 Nobel Prizes for it. I think she should probably be in there somewhere. So I went through and I had a look at how it compares with the outgoing syllabus and the incoming syllabus. The outgoing was the 2005 syllabus, and the incoming is the one introduced in 2017. And I counted the number of scientists mentioned in physics for the outgoing and incoming. So outgoing, there were 47 scientists, mentioned almost 100 times, and most of these were unavoidable, or a large fraction of these were unavoidable, and that simply means they were someone's law or part of an equation. That's not really the actual scientist that's being mentioned, but it's the law that's being mentioned. This is compared to the incoming syllabus, where there are definitely less scientists and they're mentioned fewer times, and there is a higher proportion of these that are unavoidable mentions. But there are still 50% of the mentions that are purely devoted to the scientists themselves rather than the actual work of the scientist. And so looking at the gender representation between the outgoing and incoming syllabus, it is a little hard to imagine for yourself. So I have done a very handy graph for everyone so you can really take it on board. For the outgoing syllabus, there was 100% men. Not a single female was mentioned. In the incoming syllabus, there was 100% men. Not a single female mentioned again, which honestly just really pretty painful to see. I can remember just going through line by line and thinking, next one, there'll be a woman. The next step point, there's going to be at least one, it's fine. But there is not a single female mentioned in the entire syllabus. So I decided to go a little bit deeper and look at how they were mentioned. I already mentioned that 50% of them were unavoidable, but how does that compare with the way that they're being mentioned? Well, in the incoming syllabus, there are 27% of the mentions that were used as examples or completely non-examinable. This means that they're used for students to just get a general idea of the topic, but they actually can't be tested on it in the final exams. So as an example, there's a section for the content focus, or a little paragraph at the beginning of each of the sections or each of the modules that just gives a brief background and a brief history of what this topic is dealing with. In this example, you can see it simply says, including Newton and Maxwell. There's really no need for this to be purely male scientists when we can also mention female scientists here. I have a feeling that there were at least one female scientist before the 20th century. So it's not like this is a hard place to put females in. Furthermore, there was another 36% of the mentions that specifically look at the way a scientist contributed to the science. So an example of that here is investigating Maxwell's contributions to. Students are not required to learn what Maxwell's work actually was. They just have to look at the impact that that work had on science as a whole, which means they're not actually looking at the science, they're looking at the scientist, and they're learning how did these scientists introduce these ideas, and how are these scientists contributing to the field of science as a whole. And that is purely male scientists. Not once do they mention a contribution of a female scientist and the impact that that had on science. So obviously this came at a real kind of end of my feminism journey where I was really fired up. The fire was definitely burning strong. I was pretty furious already that I'd not known about a lot of the specific issues that women face in science. But then to also learn that that actually goes right back to high school, and that we're teaching the next generation that women don't belong in science, and that it's only a place where men have contributed and are only the ones that are going to contribute. It pretty much, I guess it threw me over the edge. I was pretty angry. And I actually did a Twitter thread about this. It's still up there. You can still have a read if you want, and follow my Twitter. But I did this Twitter thread and kind of highlighted the issues surrounding the fact that there's an HSC syllabus that doesn't mention any women. And the New South Wales Education Standards Authority, or NESA, actually replied to this Twitter thread, which was pretty amazing. I didn't actually expect to get an answer, but it had started to go viral, which is pretty amazing. And a lot of people seem pretty outraged that this could be a thing. So their response, though, is not really what you want to see. They basically said, sure, the physics syllabus is bad, but have you tried this completely other science course? Because that's got 2 women, including Rosalind Franklin, which, let's just clarify, it's Rosalind Franklin, so they couldn't actually get her name right. And I was a little curious, is she even in that syllabus? So I'd only really been looking at physics, but I decided if their whole approach to arguing it's fine to not have anyone in physics because we mention them elsewhere, I should really just check that they're actually mentioning women elsewhere. So I decided to go through 8 different courses in New South Wales for science high school students, and found that there were 80 men mentioned, and they were mentioned well over 100 times. The women, on the other hand, there were 4 women mentioned 4 times. Those women were Marie Curie and Barbara McClintock, both Nobel Prize winners and absolutely, I guess, deserving to be in there. But the other 2 women were Edna Krabappel and Maggie Simpson. So first of all, Rosalind Franklin was not actually in any of the syllabuses, not even in biology, but Watson and Crick are. But there are just as many cartoon characters as there are female scientists. And I don't know about you, but I don't really picture this image of Edna Krabappel and Maggie Simpson when I think of them as the Simpson characters. They're notoriously not really the sciencey type. And in fact, the only reason they're even mentioned in the syllabus is because a male scientist published under their pseudonym because he was publishing pseudoscience. So it's not even them as characters, which is just too much, really. So there's just as many cartoon characters, but those cartoon characters aren't even related to the characters. They're related to men again. So I pretty much had enough at this point that New South Wales Education would basically try and deter the problem to point me in other directions and other courses. So I decided to start a petition about this and get the word out there. So I started a change.org petition. It's still running. As of the other week, there was over 100 signatures. If you haven't signed it, please do so at change.org/IncludeHer. It's really vital that we kind of get as much support for this as possible, because again, one of the arguments that New South Wales Education has about not including these women is that there's simply not the support in the community to justify making these changes. So this campaign is really important in showing there is definitely the support amongst scientists, amongst teachers, and amongst other STEM organizations that really want to see this change included. The only people that don't is New South Wales Education. So we really need to work on showing that that's the case. But this was really the start of the IncludeHer movement. And most of the backlash that I've gotten, it's been quite a journey, but most of the arguments that people have against the IncludeHer movement is, well, things were just named after men, and so it's not their fault. Well, that's, again, I've already shown wrong, because 50% of the mentions literally look at specifically the scientist and not their work. They argue that women haven't contributed. Well, again, that's just frankly wrong, and that we're focusing on science, not science history. But again, that's not true. This syllabus does look at science history, and I think it's an incredibly important thing when we're teaching to make sure that students have that overarching context so they can place this knowledge within the larger field. It really helps students understand those really complex problems and build upon a foundation much easier. So none of these things are really true. Maybe I'm pushing a feminist agenda. I don't know, I guess I am. But that's not really the point. Things are broken and they need to be fixed. In terms of the women haven't contributed, I decided to see how much had they not contributed. And I actually went through every single syllabus and every single dot point on that syllabus, and I looked at who had done that research. And I found that if a male had done that research, they attribute it to the male, so-and-so's work on such and such. But if a female had done it, there was just no mention of that scientist. So I went through and I provided a list of places where New South Wales Education could easily introduce women without actually changing any of the content. So for example, analyze evidence, including data and models, that supports a theory of plate tectonics, including but not limited to the profile of the ocean floor. Now that profile was actually done by Mary Tharp in the 60s, I believe. She was ridiculed by her male superiors. It was only with the same claims that Murray had, that they started to take it on board as actual science. We do know that she was the leader in this area and at the forefront of this discovery. So I just proposed, why don't we change it to Tharp's profile of the ocean floor? This doesn't actually change what students learn, but it attributes the science that's already there to the female that actually did it. Just by doing these changes alone, that don't change what students learn, they don't change what teachers need to know in order to teach this course, but just making these changes alone, we can increase the representation from 1% to 32% of the mentions being about women. Per subject, we're looking at many more women in each and every subject. Biology can have more women than men. Physics is, again, still only about 50% of the men, but still a vast improvement from the 0 that were mentioned before. And investigating science, even though there's one woman, we can still fit another 14 women, again, without changing anything really quite dramatically. And so these changes are not drastic. I don't want to put the workload on teachers. They already have a lot on their plate. And I already mentioned a lot of the funding isn't going towards training these teachers. So a lot of these changes need to be minimal effort for the people that are going to be teaching it and learning it. And that's something that's really been the focus of this movement. It has started to get a lot of ground, which is fantastic. A lot of people are jumping on board, and it's really heartening to see people realizing that that's actually a fundamental flaw in our education system, that we just completely overlook the contributions of women. So there's been lots of articles that have come out with the Sydney Morning Herald, The Conversation, Women's Agenda. And actually, while I was preparing these slides and checking some numbers and getting some research, I would Google and find more articles that I didn't even know about that talk about this discussion, about this movement and what it means. So this has really kind of grown to a national discussion now. I'm moving beyond New South Wales. That was just where I started, but it is a national problem. So has it been successful? Well, in New South Wales, the New South Wales Standards Authority still won't commit to any of the changes that I've suggested, but I am actually in conversation with them. So we've had several meetings discussing ways that we can implement that and a timeline, as well as discussing what sort of things we can be implementing as well. The really big positive thing about making this such a visible issue is that a lot of teachers have seen it and not realized that it was even a problem in the first place, and have now made their own pledges to include women in their classes, even if it's not a part of the syllabus, which is really a great first step. It means that we can introduce women in these classes pretty much immediately without the need to go through this bureaucratic process. So that's a really great first step. In terms of the future directions, I'm actually looking at going through state by state, as well as the Australian curriculum, which both are not great. I recently went through the Victorian system as well as the WA system just for physics. In the Victoria system, there are no mentions of women also, but there's a few mentions of men, but every single one of them is to do with so-and-so's law. So there's no mentions of the male scientists. I don't think that this is actually better. I think that when you're cutting that science history, you're really actually limiting the view and the history and the context that students really need in order to grab onto those really complex issues. I found the WA syllabus was really similar. It looked at the applications of physics rather than the physics itself and the knowledge and development of that physics. So there's definitely progress to be made. I've chosen WA and Victoria simply because I'm in WA at the moment and I'm sick of getting 6 a.m. wake-up calls. And Victoria because I think that would hurt New South Wales the most. In terms of the Australian curriculum as well, that would be going just a step above. That requires each individual state to include something about women, which I think would be a great long-term direction. But all of this really actually just came back down to one thing, and that was when my mum said that if something's broken or you see something that needs to be fixed, just work to fix it. I came across this syllabus and I was outraged to see that we're literally misrepresenting the science and we're not showing it correctly. And I wanted to see that fixed. All of this has just come from seeing something that was wrong and needed to be fixed. And I think that that's the best way forward for issues like this is seeing something that's wrong and working towards the best solution for that issue. I don't think that there is going to be a one solution fits all. And it's just going to be something that we'll all have to work together where we can and when we can. But as I've put there my email address, and I've just realized my Twitter and my Instagram are actually flipped. So Twitter is underscore and the Instagram is dot. But please contact me in any of those spaces if you would like to get on board and help out, or if you have any questions about this campaign. I'd love to hear your point of views, and I really look forward to having a discussion with everyone here now. Thank you so much.
Thanks a lot, Kat, for this great talk and for raising awareness on this important issue. I think I'm not the only one to be dumbstruck by some of the facts that you mentioned. So you raise a number of points which be interesting for further discussions. I suggest we start with questions for you from the audience before moving progressively to more specific discussion points. So as a reminder, if you want to ask a question or contribute to the discussion, please raise your hand, which you can do by clicking on the participants button. You should have the option at the bottom of that window, and I can then unmute you. Yeah, I see a question from Felix.
Hi, so I just was wondering, how obvious is it to the people reading the syllabus, either the teachers, I guess, or the students, that the people in question are men or women? Because they're referred to usually by their surnames. And I mean, as you said at the beginning of your talk, there's a kind of cultural bias which leads people to immediately assume that scientists are male. So if you see an unknown surname for the first time, I thought would be that they would assume it's a man anyway, even if it was a woman, unless you make some additional clarification.
Yeah, it's a really good point. And a lot of the mentions, yeah, as you say, you hear the last name and immediately assume male. I think there's only really one example of a last name where people know it's female, and that's Marie Curie. You see Curie and you think Madame Curie rather than...
Even then, some things are named after her husband instead.
Yeah, but it's definitely true. There is an absolute bias to assuming that when you see a name, it's a male scientist. I think in terms of the way that they're mentioned, though, a lot of it is specifically looking at the scientists themselves. So the ones that look at just a name are usually pretty recognizable names like Newton, Maxwell, and so on. So it's fairly clear that they're men because we're already quite familiar with them as scientists. But a lot of the unfamiliar names do actually have a separate section about the scientists themselves and about the work that they've done, a separate dot point. And teachers often introduce that scientist because it's already mentioned in the syllabus as so-and-so's work on this problem. Teachers interpret that as, I have to teach what this scientist did on this problem. And so they always sort of bring up this scientist and who it was. It also is used as examples in textbooks, and they'll have, you know, often little paragraphs to the side that's not really related to what's going on, but it's a good contextual background. And they're usually always men because the dot point will say this male scientist's work. So you see the little background information in textbooks, which is always male scientists because it comes from the syllabus document. So there is definitely a bias that you will assume male instead of female, just seeing the name alone. But when we introduce the female names, it brings in those sort of other aspects and introduces females into the classroom where they wouldn't otherwise be, and into the textbook as well, where they're just overlooked.
Okay, thank you.
No worries, thanks.
Thank you. Any other question? I see Rosemary.
Thanks, Kat. It was great hearing the talk again. And I was just wondering about the composition of the New South Wales education, or people in charge of the physics curriculum. Are there many women amongst them?
So there's one main person who's written the majority of the science courses, and then they had sort of a group or a panel that reviewed them and developed them, I believe. The panel, I think there were a few females. I'm not entirely sure of the percentages, but I think it was something that they were quite aware of. The actual problem was they didn't have many physicists in that panel, but they did have women. But the person who actually wrote the syllabus was a man, and that's who I'm actually working with at the moment to introduce these changes. I think it does highlight the issue that the panel there, they did focus having on women on board, but having none of them as experts meant that no one really knew the background enough and knew the content enough to introduce these females as well, because it's not something that the general public is aware of unless you're really immersed in this field. And even then, a lot of actual physicists still don't know of these females. And so there were a lot of things that were overlooked, including equations. They went to introduce vectors for high school students, but they didn't consult any physicists or mathematicians. So all the equations were wrong. And that was because this board didn't really have the technical expertise. Those equations were fixed when they were mentioned as being incorrect, but showing that it's an incorrect representation of scientists has not been fixed in the same way yet.
It's bizarre that they don't have experts. You might mention to them that they could include the name of Emmy Noether, whose ideas, modern physics is all about symmetry, and she, if Einstein was alive, he'd tell you how.
Yeah, Noether's theorem is definitely on my list. I think it's pretty fundamental to modern physics, and just a really revolutionary idea. So something that you don't even need to know the details of the physics to know that just the symmetry is such a crucial part of physics. I think it's a good enough concept that students can actually get a really deep understanding of quantum and particle physics without needing to know those really complex ideas as well. So yeah, Noether's theorem is definitely on my list. I think it would be a fantastic addition to the syllabus.
Excellent.
Yeah.
I see Bernard.
Yes. Hello. Yes. You mentioned you had a list of. So you went through the syllabus and found, various women physicists to mention. Did you have a list of women physicists? Because I'll admit I don't know much about historical women in historical physics. Like, for instance, until about 10 seconds ago, I didn't know that Noether was a woman.
I'm putting my sound back on. I'm heartbroken, Bernard. Heartbroken.
There's always room to learn, and it's never too late to learn.
Spread the word. Oh, man.
I actually didn't have a list. I was actually pretty similar. I didn't know many women. I grew up in this syllabus that didn't mention any. And by the time you get to university, there's really a lot less of a focus on inclusion in that way. So no, I really didn't know many women scientists at all, and let alone outside physics. I was also looking at earth and environmental. I haven't ever done any geology. I don't know things about rocks. So I certainly don't know women in that field. But what I found was literally just Googling the research, the profile of the ocean floor. I literally just Googled that and saw who was involved, and it's Marion Tharp. So a lot of this literally just comes from one night of Googling a syllabus and finding that women are well and truly embedded in this syllabus. They're just anonymous and they're just not there. So it's not hard to find them, and it's really not hard to actually include this information. It just takes a bit of thought and preparation. Yeah, but I don't think it's too hard for anyone to really work to do it. Yeah, if I can, hopefully anyone can.
Yeah, I see Michelle.
Hi, great talk. Given that most of us here on this Zoom session work at a university, what would be your advice to those teaching classes right now to be able to include better representation of women?
That's a great question. And I don't know if I have a good single answer for this. I think there's a lot of things that we can be doing in the university space to make sure we're promoting inclusion. From as simple as in your classroom, making sure, doing exactly as I did, going through your syllabus and making sure if there is any science that was done by a woman, that you actually take time to focus on that for a little bit and really highlight that women were involved in this field. I also think it's important to take note of things like the contributions of women within the actual classroom. There's studies that show, this is more in high schools, but there are studies that show that men take up far more talking time in classrooms than females, and often will interrupt the females completely, and females just sort of sit back and take it, and the men take that space as their own. And so being aware that those things can happen in your own classroom, and making sure that you are actually encouraging and engaging with the females in your classroom to make sure that that's sort of as minimal a thing. Ideally, I actually would love to have universities also have a whole section devoted to the history of women in science, or the contributions that women have made through science for any science degree. I think that it's such a vital part that we make sure that people know a lot of things aren't mentioned after women because of historical biases and sexism, not because women weren't there. And when you don't really mention it, it's the same thing of, you know, if you're neutral, you're on the side of the bully rather than the person being bullied. So if you don't mention this issue and you just stay completely unaware of the issue, then you assume that women weren't there. That's why they're not mentioned. But we all know that that's just wrong. So I think that there should be an outright explicit mention of women in certain fields as well. But that's definitely a much longer term goal in terms of making that like a unified thing across universities, starting with high school, and then let's move to uni. I'll move up from there.
I see Amber Tilly.
Hi, I'm not sure if it's much of a proper question. I came in a bit late, but so I'm currently studying science at university, and I have noticed that there's a lot less girls in my class, but also whenever there are, you know, problem sets or assigned questions, I have noticed that a lot of the girls have said things like, oh, sorry, I'm so dumb, you know, I can't do this, I'm not smart enough for this kind of thing, or, you know, they just really lack all confidence in their abilities. And I guess it's just an observation of mine, but also there's not really that kind of feeling when I talk to the male students, and I'm not sure if that's like how we're raised, or like just, you know, coming straight out of high school, like because we don't have, I guess, female mentors we can see, or female people who are confident in maths that we see regularly or something like that. Like, I don't know if that's also what causes us to, you know, not have our own confidence in pursuing this kind of career, because it is a lot harder, I guess, but, you know, it's to do with, you know, confidence and practice and all of that. So.
Yeah, there's actually a lot of research into self-efficacy, which is a measure of how students can judge their own abilities compared to their peers, and also their ability to set goals and then work to achieve those goals. And there's a lot of studies that show women have lower levels of self-efficacy because they're unable to put themselves in an accurate position in regards to their peers, and will often put themselves way at the bottom when there's actually no noticeable difference between them and their peers. And likewise, their goals are often really unachievable because when you look around and you see so few females around you, and then you look up and you see professor only, a single female professor, you look around and think, well, only one female gets through. Do I feel like I'm the best female here and I'm going to be the one that becomes a professor? And obviously not. You're an undergraduate. You don't think you're, you know as much as a professor, and you don't, because you're an undergraduate. That's what it's about. But when you're faced with that kind of conundrum, it really hinders that self-confidence as well, because you're like, well, I'm not going to make it anyway. Only one person does, and I'm not the best. So why am I even trying? And then it sort of fuels that I'm bad at doing this, and it's sort of a downward spiral from there. And I think a lot of the time, one of the issues with imposter syndrome is that any success you even have, you actually attribute to an external factor anyway. So I was lucky, or I had a lot of help, or, you know, this was only by chance that I found this. Whereas when you don't suffer from that, you get an achievement and you're like, yes, I'm amazing, I did this. And I think that happens as well when in reverse, when you are doing things poorly, or if you get a bad mark, that's because I'm dumb or I'm really unfortunate and bad at this. Whereas if you aren't lacking that self-confidence, you might be going, oh, it was just a hard test, or I had a bad day, and might attribute it to an external factor. So it is a really complex issue, and there's a lot surrounding it. And I don't think that there's any one best way to solve all of it immediately. But I think even just being aware of these issues and highlighting it to students and bringing it up in class is a great way to just start that discussion and help students move through these tough times.
Yeah, thanks.
Power through, you'll get there. Don't listen to your head.
Yes, Rosemary.
Well, me again. Yeah, Kat, you mentioned this the last time you gave your talk. The elephant in the room is the fact that there are very few women, in the last 100 or 200 years that contributed to physics. And that's because, as you mentioned last time, we weren't given the opportunity. And it's, you use the example of a geologist rather than a physicist to, show. So in your Google searches, did you find many women? Oh, you had a list. Oh, you had a number, but
yeah.
But my main point is that we weren't given the chance. That's you said that students need to be told that.
Exactly.
Right?
Yeah, the fact that we have fewer numbers is not because we weren't there and we weren't good at it. It's because there were societal structures in the way and hindering our progression. But even despite that, we still have heaps of women that have contributed to science and physics as well. There's still plenty of us here that they've tried to stop us, but look, we're still around, we're still doing things, and we still have made contributions to science throughout history as well. So yes, there are less things named after us, but that's not because women weren't there and weren't contributing. And yeah, you're right. It is important that we mention these things and we highlight them so that
the reason why we weren't there, not because we weren't smart enough. Yeah.
Exactly. Yeah.
Yes, Michelle.
Cool. Hi. One more question. I was wondering if you know anything about the psychology behind the need for a role model that you identify with. Like, why is it not enough for a woman to see a human being succeeding in physics? Why do we need to see other women?
Yeah, that's a very tough one, and it's difficult because it's only a new field of research as it is. We've only really started in the last decade or two to actually look into the psychology, as you say, and into the science behind why there are these biases. And I don't, again, think that this seems a bit like a cop-out answer and I'm repeating myself, but I don't think there's any one solution and there's any one thing that's causing it. But I think we are such social creatures, and we do like to see people like us and relate to us and know that we're in a comfortable environment. And if you look around and see no one like you, but you see everyone like you over here doing something else, when you're bombarded with that every day, it's really hard to deny that and not take it to heart. So I think it comes from having a society where we really force that strict gender role and force these ideas of role models, and you have no escape from it. And it can become just an easier outlet to take the route where you'll succeed because there's plenty of people like you. But I think it is such a complex issue, and I don't know of any specific research into the psychology behind it. I would say it's simply just because we're social creatures and we like people like us, probably.
Yeah. I actually like to jump on this question to share my experience of a successful example where showing female role models to young students has led to a fair representation in science. So I did my studies in Belgium, and throughout my bachelor in physics, we had a 30% female ratio. And during my master in astrophysics, we had exactly 50% female ratio. So I remember a lot of people were pleasantly surprised by this high fraction back then. And retrospectively, actually, I think I can pinpoint a few reasons for that, and most of them you were mentioning in your talk, Kat. So first, throughout high school, I remember female contribution to science was rightfully mentioned, including, of course, mentions to Marie Curie, Rosalind Franklin, etc. And during that bachelor in physics, also we had a course of introduction to astrophysics, where the professor in charge, albeit male, made a clear point that female astrophysicists did make significant contributions and contributed to key discoveries in astrophysics, and were often not made sufficient justice. So you mentioned, I remember Jocelyn Bell, Henrietta Leavitt, the team of female mathematicians at Harvard that contributed to the stellar classification system. So this, I think, contributed to more female students moving to astrophysics for the master, which led to a 50% ratio. Then beyond the presence of female role models in the curriculum, I think another factor that might have contributed to this is their presence in the media. So I think this was key. So if there was a breakthrough made abroad, which did not directly involve someone in Belgium, then the interview would be made to a local expert in the field. And as far as I can remember watching the news, I'd noticed quite often, at least as often, female scientists being interviewed as male scientists, which gave me the impression when I was young that there were equal amount of female and male scientists. So this is actually an important psychological factor, I think.
It is. You have to normalize it. If you're normalizing that women are there, it doesn't seem odd that you could be there as a female. Yeah.
Exactly. Yeah. So I totally agree with you. It's really important. It's crucial to inspire young students with a fair representation in the media and in the curriculum.
And there is also research that shows the Superstars of STEM program that's been happening for a few years now, where they select female scientists, early career researchers, and they sort of teach them the best ways to present their science and be out and visible as a role model in STEM. And we can actually see the effect that that's having. It is slow progress, but it is making an effect. So by normalizing it, as you say, and having these female role models everywhere, both in class and just in the media, just brings the idea that it's completely fine for a woman to do so.
Yeah.
It's a really good point.
Yeah. So I know, Isabel, you have some more questions you'd like to ask to our speaker?
Yeah, sure. I can ask one of the questions that we prepared earlier. So one of these questions is, what would be your advice to somebody who thinks that they've seen an example of institutionalized sexism but doesn't know who to talk to about it?
Yeah, this is a very difficult one because you want to be able to call it out as it's happening and stand up. But I realize that a lot of situations are complex and you're unable to do things like that because of power dynamics and even just, your ability to actually say something. So if you think you have seen something and you're uncomfortable with what happened, I guess depending on who it was that was being, you think, harassed or had some issue happen to them, and who was actually perpetrating it, I try and speak to someone higher up that you're comfortable with, that you know will actually sort of back you up on this, and maybe even approach the person themselves that was hurt in the situation and just say, I noticed this and I was uncomfortable. I wanted to see how you felt. And if you want any support, we can both together go and see someone about it. There are a lot of unis that have things in place where you can anonymously step forward and say things. But again, I realize that that's difficult sometimes, especially if someone in that group is the one that's causing the issue, and can make things definitely very hard. The best thing I can do is talk to people that you're comfortable with for advice first about the issue and the person involved, and see what they want to do moving forward as well, because they may not want to make it a big issue as well, and they have that right if they so desire. Does anyone have any comments on that? I think it's a difficult issue, and I don't know that there's a perfect solution.
Okay, I don't see any hand raised. So, so you were mentioning a bit earlier a few ways to go beyond beyond representation in the curriculum. So let's discuss maybe about that. What's currently being done and what could be done better beyond the curriculum, like outreach, public talks by female scientists, visits of female scientists to high schools and primary schools to talk about their work, or visibility in the media. What's your view? What's our audience view on what's currently being done and what could be done better?
I think we're doing great steps at the moment to try and make more visibility for women, but there's still definitely a lot of work to be done. And there's a huge issue with the fact that if you require women, you know, on every panel, and we require women at every talk, and every expert must be a woman, you get a lot of fatigue being a woman that's required to give all these things. And also that's a lot of time that then is taken away from your research. So I think in terms of institutions, we can do a great job of looking at the broader picture when hiring as well, and looking that there are going to be women that have less things on their resume and have fewer papers because they're doing this work on the outside. And to me, I think that that's as important as papers, because that's looking at the long-term goals of science when we're introducing the rest of the population. If you're actively hindering 50% of the population, we're also hindering the progression in science. So as an institution, I think it's big that we can look at the ways that women are working outside of their actual research and consider that in an application. But also, recognizing that we should also look to making sure that women are feeling comfortable and able to do as many sort of outreach and media things as possible. And that comes with valuing that work as well. It's a hard one as well. You do want to normalize it, but you also want to make sure that women are able to do it and they're not getting fatigued from this. Yes, and it's a really fine balance. Yeah,
I agree. That's an additional burden, extra work, definitely. So I was wondering what's currently being done here in Australia. Is it common for scientists to visit high school or primary school to talk about their work? I remember when I was doing my PhD in Chile, we'd have quite often female colleagues going to high schools, talking about astronomy, and so giving the example of female role models in high school, basically. And I think that was also helping to get to a fairer representation of female in science. I wonder, is this done in Australia at the moment?
I never had too much of an experience with it. I know it does happen, but I don't think it's a very common thing. I think it happens every now and then. And it's particularly difficult in low socioeconomic areas, but maybe there are other people that have more experience with this than myself that may want to.
Yes, Rosemary?
Me again. Yes, I used to do that a lot. Probably, yes, the 90s and 2000s, it counts for absolutely zero for your resume. It's negative because, as Kat says, it takes away from the only thing that does count, in spite of the rhetoric, and that is research and papers and grants. That's it. So I loved doing it. I really loved doing it, but I stopped because it just took too much time.
Yeah.
And for nothing. It wasn't even acknowledged. Yeah. Anyway, bitter old woman.
Yeah, and that's something that I think is quite common. It's even something that I found when applying for my PhD. I did a lot of work already on outreach and was doing this campaign at that stage when applying for my PhD, but there's nowhere to put that on your applications. There's nowhere to say, I do work on the outside. So no, I don't have a paper, or I don't have this, but I do actually have chapters in books about scientists and representation. So it's difficult to try and, there's not really the space for you to bring that forward either. And I actually, it's just brought to mind, somewhat related, but not really. And I think it's still worth mentioning. The undergrad student who asked a question before, and I can't remember your name, but the talk of, women often will be like, oh, I'm bad at this and I'm not good. And we can see a measurable effect in grades and in exam marks as well. And this was something I found personally really bad in undergraduate is you'd want to look forward to doing a project with, you know, a professor and doing one of these summer projects or research projects. But when your grades are really poor, that's all they look at and that's all they care about. But my actual research work and my assignments were all fantastic because I could sit there and work on the problem. But I'm not someone who does well in an exam where I have to sit there in a short space of time and really churn out the answers quickly. Not a skill that's necessarily needed in research though. It's clearly not hindered me once I've gotten to my PhD. I can doing fine, so that's great. But it's something that was really hard to justify in order to get into your research project. So as well as looking at the whole picture for academics and hiring in that sense, I think we as an institution should also be looking at the undergrads and realizing that grades are not the be all and end all and the perfect measure of a student's capabilities. And forcing such a big, such a big focus on the importance of grades really can hinder women because they don't think they're getting their grades. Even if they are, they don't think they're doing as well. And so will often not apply for these things or not get into research projects. Yeah, so I think a shift away from grades and marks is also pretty important.
It takes resources and time, though. You know, in Oxford and Cambridge, you've got 2 students per tutor. Here, we can't afford to do that. So how do we come to know how good students are? We do write to the students who are doing well at the girls, and suggest, have you thought about doing a research project and so on. So we are, making some inroads.
Yeah. And that's great steps. I mean, wish someone had written to me, but I will.
Yes, me too.
Is there any other question or point that you'd like to raise? If not, let's all thank Kat again with a virtual clap. Yeah, thanks a lot.
Thank you, everyone. Thank you so much. It was really lovely to come and chat to you all again.
Yeah.